Have you ever wondered where that enormous force comes from when two cars collide? You might think it's simply one object pushing against the other, but in the energy filament theory, the collision isn't as straightforward as two objects physically smashing together. It's not just about every single atom slamming into another one. This is the kind of event you see in particle accelerators. In everyday life, though, when objects collide, what really happens is that two already existing tension pathways, each with their own pre-established structure, are forced to merge and adjust in an incredibly short span of time. This sudden and intense realignment causes the energy of the entire tension field to redistribute itself rapidly. Picture this: two groups of people walking in opposite directions on separate lanes. Both groups are in sync, walking comfortably, and underneath them are invisible treadmills representing the tension pathways. Suddenly, the lanes intersect, and these treadmills can't pass through one another. They must immediately switch tracks at the intersection, forcing the people at the front to stop, twist, and turn around. As they adjust, the entire group behind them also has to change its rhythm in response. What you see are people being pushed around, but what the energy actually sees is two pre-existing tension networks coming together and recalibrating at that point of intersection. Let's look at the simplest form of this: a collision between two solid balls. When a billiard ball rolls across a table, it follows its own straight path, moving in the most energy-efficient direction. The real contact happens between the very thin surface layers of the pads. When the balls collide, they must immediately adjust and recalculate the most efficient way to move next. Some of the kinetic energy is redirected into different directions, some is transformed into rotation, and the remaining energy is absorbed into the felt covering of the table, causing slight vibrations and a little bit of heat. This isn't an atom-to-atom collision, but rather a moment where two energy pathways realign in an instant, recalculating how they will continue. Now, let's take a more complex scenario: a car crash. When cars collide, the impact zones, crumpling zones, and cushioning materials absorb the energy. The car's body bends, steel beams deform, and parts break off, while the energy of the car's initial movement, which was concentrated into speed, gets transformed into various types of deformation. The car's body absorbs the tension, metal stretches, glass shatters, air gets disturbed, and sound vibrations radiate outward. The direction and energy of the car haven't vanished but have been redirected into many more specific pathways. What seems like the car shattering is simply a redistribution of energy into a new, more efficient shape. What's left behind is what appears to be broken fragments, but in reality, it's just the energy pathways realigning to a more favorable configuration for the entire system. The same principle can be observed when you hit a sandbag. The energy you apply with your fist travels through the bag's interior. The sand and fibers inside break up the rhythmic forces, transferring it into heat, deformation, and overall movement. The sandbag shifts slightly, and the rest of the energy dissipates through microscopic vibrations and noise that spreads into the air. The impact force you feel isn't the sudden appearance of a mysterious force but a realignment of the tension pathways. These pathways, which were previously in place, are forced to recalibrate to an alternative route. This recalibration happens in a brief moment, and the resulting shift in energy and movement is what we perceive as an impact. This concept of force and collision is much more about the realignment of these energy pathways than about some external force appearing out of nowhere. The energy of the system is simply redistributed, and the resulting collision is just the manifestation of this energetic recalibration. Understanding this recalculation, whether in a car crash, hitting a sandbag, or even the movement of celestial objects, helps us understand that what appears to be destruction is actually just a shift in the most efficient energy configuration. Next time you see a crash or collision, don't think of it as just a moment of brute force. Instead, think of it as two systems recalibrating, shifting energy, and adjusting pathways to form a new balance. In the next episode, we'll dive into how the four fundamental forces — gravitational, electromagnetism, weak nuclear, and strong nuclear forces — are often taught in textbooks in isolation and fail to explain the interconnections that might be at play. Tap follow, share it on New Physics, Clear Universe.